Okay, hello. I thought I would do things a little bit differently today. Since we're not meeting in person, I thought again I would do a recording instead and allow you guys to work because I know you have your paper due and want to get that done. That's more important than anything at this point. And the two chapters I'm covering now, 14 and 15, they're good wordy chapters in that we're discussing these topics that are very difficult at times to understand and to implement because we tend to apply causal and we tend to apply causal relations almost arbitrarily with whatever we feel fit at the time. Uh, I once was standing in a line waiting to catch a bus slash it was like last year actually, and we were at an air show and it was terribly disorganized going from the parking lot to the show venue. It was in Reading at Reading Airport, and we're waiting at this field, waiting for these buses, and I overheard people standing next behind me. This guy said, "Well, the COVID vaccine killed more people than COVID." So he made this attribution of a causal effect without providing any evidence. Perhaps he heard it from somebody on some talk show or something like that, but that's an example of a causal inference that can be made. And now what it does, when somebody makes that inference, it puts the onus on the person challenging it to find all the data. So somebody puts out this statement, and then his friends will probably agree with him because they have similar, mindset. Then now somebody who wants to challenge it has to go out and look for the evidence. I mean, I heard that. I did hear it, but if I wanted to, what I would do immediately start looking at the research to look at the any links between deaths, even though I know that's not true, but I would still want to look it up in order to present evidence to demonstrate that this causal effect that he proposed or as truth is wrong. So this is something that we really need to do, but reading through this chapter and the following chapter, one should realize that it's difficult to determine causal relation between a predictor and an outcome. Generally, when we're proposing a causal relation, we have one variable that we consider the cause, and we have another variable that we consider the effect. So we have to somehow propose that the change in that predictor is going to have an impact on the effect. This is something we discuss as internal validity. For a study to be internally valid, manipulation of the independent variable has to be the sole cause of change in the dependent variable in the outcome. And I'll go over a scenario with you shortly, and we can use that as a I guess a template to finish up this discussion. But before I do that, I want to talk about guidelines that we use for judging a causal relation. So it's interesting that thankfully, as we can see, the Surgeon General Advisory Committee back in 1964 came up with some great criteria. They're not perfect criteria, but they're really great criteria for judging a temporal relation. They say relationship, you know how I am. It's relation is for variables, relationships are for people. They obviously didn't work with me and the professors I had at Maryland. So let's go over these and just keep in mind that this presupposes much. Like we said, that there's a first one, there's a temporal relation. It means that the cause, the putative, and I say putative as a supposed cause, precedes the outcome, right? This has to occur. Right? For instance, if I'm studying cigarette smoking, does cigarette smoking cause cancer? Well, if cigarette smoking precedes lung cancer, then we can say, okay, well, there's a temporal relation that makes sense here. If, on the other hand, people start smoking after they get lung cancer, then obviously that wouldn't make sense. One has to precede the other. Well, it's interesting here, and this is discussed more so, I think, in chapter 15 is the quality of the data that we get is important because it's not always we can't always trust everything that's being done in studies. And that's why I said this is such a difficult chapter or set of chapters because there's a lot that goes on into determining a causal relation. I just say, oh, there's a temporal relation between the predictor and the outcome, but somebody had to measure the predictor variable and the outcome variable and control for confounding variables. All that stuff has to be done. Otherwise, what we're proposing or what we're considering a temporal relation doesn't even make sense. So there's so much involved in here, so much involved here. But we want to have that. I mean, and to do that, we need studies that have measured temporal relations, right? We have to have something, whether it's a case control study or a cohort study, something has to be done where we can propose that relation. In my work, we always looked at, in my prior work, we always looked at the predictor being something like exposure to peers who smoke and whether or not that impacts smoking, right? So, of course, we couldn't, as I've mentioned this many times and hope you've appropriated it, studying lung cancer as an outcome or any outcome in a disease that takes decades to manifest is very difficult to do. That's why we do case control studies. So we can, because we have people who have cancer and people who don't, and then we can look and see what was there a relation between the two, right? Between the disease and exposure. So at minimum, we want that, right? A temporal relation. Strength of the association, the stronger the association, the better. The more likely it is to be causal. But as we know from what I've probably discussed with you many times, and whether it's in this course or other courses, just because two things are related doesn't mean that they're causally related. There's many different ways to study associations. We can look at simple correlations. We can look at a contingency table and do odds ratios and relative risk and use chi-square tests, all these different types of tests to determine if two things are related to one another. But just because they're related doesn't mean that there's a causal link between the two. They can just be spuriously related. I'm glad your author brought up spurious correlations. It means they're just there accidentally. They're related to some third variable, which we'll discuss in a moment, confounding variable. So that other variable is what's responsible for the relation between the two variables we see. And that happens often. That's why you should only be minorly excited to see things related. Obviously, you want them related because if they're unrelated, then that negates your chance of studying a possible causal relation between the two. However, just because they are related, you should like temper your excitation and say, well, maybe there's a confounding variable in there, right? Maybe. So we always have to account for that. Dose response relation between the two. Well, I mean, the higher the dose, the greater the effect, right? So the more, so like if you look at something like asthma, the greater the exposure to, say, some allergen, right? The greater the response, the asthmatic response. So that you need that dose response. Just say similarly, if you reduce the dose, you'll have a reduction in the effect. That kind of goes to number 7 in the cessation of exposure. If we remove the effect, then remove the cause, the putative cause, the effect should disappear. In fact, there's types of studies that are done, single subject designs where we look at people, follow people over time. We start by introducing whatever the putative cause is, and we establish a baseline in the response. Well, actually, let's start before that. We establish a baseline tendency to respond without the exposure. So for I guess if we're looking at an allergen and its effect on asthma, we'd want to not have that allergen present, and we would want to check somebody's breathing. We do this, I think it's expiratory volume or something like that. I've done it before as an asthmatic. We breathe into this tube and we see how well your lung capacity, how well you can do. So we'd want to establish a baseline with that by doing repeated measures. we'd introduce the pathogen and we'd expect to see in this dose response association, we'd expect to see an increase, right, in asthma symptoms. Then after a while, we'd remove the pathogen and then see, we'd hope that things would return to baseline. So cessation of exposure can actually be a really good way to look at it. It includes both dose response and the elimination of the exposure with its impact on the response. Replication of findings. This is such an important factor in judging causation. In fact, as a journal associate editor, I, I'm always reviewing articles, and most times people propose no novel ideas, probably because they did dissertations for their doctoral studies. And when they did their dissertation, they decided, hey, I'm going to do this novel study because in a dissertation you have to do novel studies. That's kind of almost like a criterion, do something that nobody's done before. But then that's just one study. For us to judge the validity of the findings, we have to replicate it over and again, right? So and why do we do that? Well, I'll answer that. It's because of if you recall taking statistics, but you'll definitely see next semester, there's something known as a sampling distribution of the mean. The mean being the expected value. It could be any kind of variable, any kind of statistical measure. So when we do things, when we collect data from samples, and the sample is a random sample. And even if we don't do random sampling, there's still kind of a randomness to the people who are participating in a study, although there is something called selection bias, which we'll talk about shortly. But you you randomly select these individuals, so to speak, from the population. You can get population samples here or there from this grand population. Some of them will be more representative of the population, some will be less representative, but they'll be all over the place. So your findings may be related to the sample that you selected on a given day or a given period, rather than a true relation between the predictor and the outcome. Right? So therefore, we need to do as many replications. We should continue to do them, but the problem is, as journal editor, one thing I notice is that the reason we get novel findings is because people have tendency, there's a bias towards publishing novel findings because replicated findings seem to be kind of boring to the general public, right? But not to me. And I'm fortunate that I can actually be in a position where I can ask for replications. And we need to see more replications. I know it's not exciting. It's not going to get you in the front uh, on some journal not website, some news outlet publishing your finding. They'll publish the more sexy new finding, supposedly new finding. There has to be some kind of biological plausibility to whatever you're proposing. The way I would look at that is you could think of something like I don't know. I was thinking of text. I'm going to use this for two things, texting and driving. So texting and driving, when we think about consistency with knowledge and biological plausibility. So texting and while driving is related to a reduction in attention. So this has to do with the limitations of our working memory. Our working memory is that memory that we have access to at a given moment versus the stored memory. So that working memory is affected by obviously by biological structures in our brain that limit our attention, and it also is other knowledge that we have. We know that there's a limitation in working memory. So if somebody says that texting while driving is a causal factor in automobile accidents, well, that proposal is consistent with knowledge that we have about our limited working memories. We can only process so much information at a time. That's why in the old days, when people used to remember phone numbers, they were hard to remember. I mean, they were easy to remember because we had like 7 digits, right? Well, I don't even know what you call those last four and the first 3 digits. So it was okay to remember because we can only handle so much information at one time. But if you ask somebody to recall a phone number, right, so then bring it to consciousness, and at the same time they're asked to do something else that they'll, kind of explode because we're taxing our working memory capacity. So biologic plausibility and consistency with other knowledge kind of go hand in hand there. Consideration of alternative explanation, that's something that should always be done. In fact, I know from my experience with just writing manuscripts for publication, submitting manuscripts, one of the things you always have to write at the end of the manuscript is, this is only one possible solution. Perhaps the alternative is the reverse. And yet this is more important when we're dealing with when we're dealing with, say, cross-sectional studies rather than with longitudinal studies or studies with repeated measures, because when we're dealing with cross-sectional studies, we're dealing with a cross-section of the population at one time, and we don't know which comes first. Does A cause B or B cause A? And so you always have to talk about that, but you generally want to make sure that you provide alternative explanations. I mean, even in things like the calculation of degrees of freedom, we have degrees of freedom. So you say when I do this something like structural equation modeling, when we're doing the modeling, the degrees of freedom indicate that we have some ability to propose an alternative model, right? There's uh, we have some ability to propose different models and test them, so we have some freedom there. So we always try to leave ourselves with some of this freedom so that we can propose alternative models. But in general, you should be proposing an alternative because somebody else will if you don't. I mean, so you should. Specificity of association. Your author does a good job discussing that this is a problem area in these criteria because specificity of association means there's only one outcome associated with the risk factor. Like I usually think of this in terms of concussions, right? There's people trying to claim that concussions are responsible for suicidal ideation we see in athletes. So for that to be using this criterion, we'd have to say that concussions lead to suicidal ideation and nothing else. But that's not true. They also lead to other factors, right? Like this what is it? Traumatic and I can't remember what is it? CTE, chronic traumatic encephalopathy. I think that's how you pronounce it, right? So it can lead to more than just one factor. So your author does a good job saying that this one we could probably get rid of. There's also a discussion here about the nature. Let me see if I can find it. The nature of the causal relation between a predictor and an outcome. Is it direct like this, or is it, let me see if they have it here, or is it mediated by some other factor? I think it's one of them. I mean, I have, like, obviously, oh, here, I guess this is one we can look at. Yeah, so when we think about causal factors, putative causal factors, we have to look at the nature of the relation between the two variables, the predictor and the outcome. The closer in proximity they are, right? Like say being smacked in your arm and having a bruise, the more likely we are to have a direct relation between the two. The more distant they are from the exposure to the outcome, we're more likely to have intermediate factors. These intermediate factors are actually what are called confounding variables. Just as a recap, and this was discussed in these chapters, the recap is a confounding variable is a variable that's related both to the predictor and the outcome variable, right? Or the what we call famously the third variable problem. In many cases, we deal with confounding variables by controlling for them either statistically, or in some studies we can control for them through matching, or sometimes we control for them by randomly assigning individuals to different levels of our independent variable. But even so, there's always going to be some confounding variables, and we have to do something with them, right? And one of the things we can do with them is to control for them through their inclusion. It's like, if we can't beat them, join them, right? So we're going to involve them in our model. And one way to involve them in our model is through having them act as mediators in the model. So whatever the risk factor is, it'll cause the outcome, but via some steps. I guess a good way to think about it is the effect of pure smoking on lung cancer, right? That's mediated by cigarette smoking. So pure smoking may have an effect, like say you were exposed to peers as an adolescent, you started smoking, and then as an adult you have lung cancer. Well, certain that's a long time between, we're talking about 30 years or so at least. That's a long time from the exposure to the disease. So a lot of things can interfere with that, but one of the most important mediating variables is smoking, because smoking is related both to lung cancer and to having peers who smoke. So the effect is channeled through, right? The effect of pure smoking on cigarette smoking is channeled through one's smoking behavior too. Then one can propose other factors as well. And let me appeal to some notes that I'm going to post for you all. There you go. Oh, where is it? Yeah, here you go. To look at moderated effect. So moderation means that there's one variable that acts differently on the relation between the putative predictor or the putative cause and the outcome. So this is a model that I show a lot. Maybe you've seen it already. I don't know. Looking at the relation between caffeine consumption, caffeine consumption, sleep deprivation, and driving performance, right? So what we have here is this is driving performance. So it goes from 0 to 10 here. And we have this figure divided into those who are deprived of sleep and those who are not deprived of sleep. So deprived individuals have a dashed line, and the not deprived have a solid line with no dashes. Then we have three levels of caffeine consumption: low, medium, and high. So what we see here is that there's an interaction. So interaction refers to moderation. Statistically, with the way we do this is we actually just, if we were doing a regression analysis, say there was so say our outcome was driving performance. It's this variable here. Our predictors are sleep deprivation and caffeine consumption. We'd want to test each of those independently to see if there's what we call a main effect. Is there a main effect for caffeine consumption? Does caffeine consumption in and of itself affect driving performance? And then we want to see, is there a main effect for sleep deprivation? Does sleep deprivation in itself impact driving performance? But when we look at the two of them together and plot their trajectories, we see that they act different, right? Apparently, being deprived, sleep deprived, results in better performance, right? Going from low to high caffeine. Okay. However, among those who are not deprived, you have the peak performance among individuals with a medium level of caffeine consumption and poorer performance at low and high levels. So this is an indicator of an interaction. Statistically, we would do this by just multiplying the two. Whatever your score is on deprivation, whatever your score is on caffeine consumption, we just multiply those together. Like say these are coded 0, 1, 2. It says 0 and 1. If you are not deprived in low caffeine, you get a 0, right? Etc. So we just do that. And we use those scores to enter, we enter those scores into, to this model, right? So we just do a product of the two. And that's how we test it. And if that's statistically significant, we have an interaction. But graphically, what we want to see is this. We want to see this crossing at some point. That's usually a telltale sign of an interaction. We'll talk more about that when we get to statistics. Yeah, but so confounding variables can be either, and we don't always deal with them, but I think it's a good idea to deal with them, right? Eliminate the possibility of an interaction, eliminate the possibility of mediation, and you'll be able to, you have a stronger paper. Yeah. I also want to talk a little bit about, maybe I'll talk about it in here when I go through this example. So I'm going to go through this example with you, and then I can talk more about issues other issues that are related with, because there's a lot discussed in these two chapters, including an extensive amount of time on bias. Because bias is so important. Bias and selection, selecting individuals to different. So when we talk about selection bias, we're talking about how we select individuals to be in our experimental versus control groups. Reading this chapter, you're going to say, gosh, why am I even planning on doing a study when it's so horrible? I mean, look, you got to deal with it, right? Easiest way to deal with it is just to admit it when you're writing your paper. There's possibility of selection bias, but we did such and such to control for it, right? So when we talk about selection bias, we're talking about there being some systematic difference in the way individuals were selected for the experimental versus the control group. There shouldn't be any, right? There shouldn't be. But even if we're just dealing with recruiting participants, the people who respond to ads are going to be different than people who don't respond to ads. So we already have some kind of a selection bias occurs. What we want, though, is that bias to be similar among the groups, experimental and the control group. Now let's just talk about this fictitious study. We're going to go through how we would design it. So we can apply things that we learned from this and other chapters here. Look, so this is grant solicitation 20180401 DR. The effects of sunshine pills on depression is, my famous drug. Thank you for your interest in applying for this outstanding grant opportunity. We find this new drug intriguing. However, grammar aside here, however, we are not sure if sunshine pills is, it's actually sunshine pill, so you have to apostrophe S after the S. Its effects are true or placebo, right? Placebo being, then a sugar pill, basically. Further, we are also interested in dosage. If the substance is efficacious, right? Efficacy meaning that it works, that it actually does work, right? Would a high dose be as efficacious as a low dose? In order perceive to receive full consideration, you must complete the following application in full. All right, so you want to operationally define your independent and dependent variables. So my independent variable here is sunshine pills. Say we have low, medium, and high dose. And we're comparing it to a placebo, so we'd have four levels of our independent variable. I'd want to define it that way. What is high dose? What is medium dose? How many milligrams, right? That's what we define here. Our dependent variable, well, what are we looking at? Dosage, I just a low dose, and what? New drug. Oh, so I don't know. We can do it with whatever. You can do something like happiness, right? You didn't really mention what is our dependent variable? It's happiness, and we always have to define it very carefully, like happiness as measured by the such and such happiness scale, right? The Philadelphia happiness scale, the LaSalle happiness scale, okay, which ranges from 0 to 40 or whatever. Usually, when you're providing information on the variables, you want to be as specific as possible, right? I would even, if I were writing this as a grant, I'd provide information about its validity, so that I'd want to do that. Clearly state the research question, including the operational definitions of your independent and dependent variables. So we kind of did it here, but we'll add it here. Like our question is, does do higher levels of sunshine pills increase happiness? That's a really good, really good question. Do higher levels of sunshine pills, as measured by low, medium, or differentiated by milligrams? So I want to say, that because that's trying to operationally define. Operational definition is a definition you can operate on. So you're told what to do. It's like when you go to IKEA and you get one of these crazy, blueprints of how to put together a shelf. It tells you exactly what to do. Although it never works out well for me. And the dependent variable was our measure of the whatever the LaSalle happiness scale, or happiness as measured by the LaSalle happiness scale. So you want to be just very, very specific there. What are the null and alternative hypotheses? Your null hypothesis is the hypothesis you'd like to reject. In this case would be there's no relation between sunshine pills and and happiness, right? And the alternative would be uh, as something like high dose of sunshine pills. Well, there's a dose response relation between sunshine pills and happiness, whereby individuals taking high dose will be happier than than those with low dose and the placebo. And I could outline it very carefully exactly what I want to have, especially if I have that many dosages. So I want to be very careful. It's interesting when we write hypotheses and statistics, we try to make them very simple, but when you get to the research world, they become more complicated. Like, if I was writing a grant, I would probably say one of my hypotheses would be that people taking high dose of sunshine pills would be happier than people in the placebo group. People in the moderate dose would be higher than the people take in the placebo group, or there'd be no difference between individuals taking low dose. Right. So I'd be very, very specific about it. And I could write down these as separate hypotheses. What is the proposed research design? So this is one where we're going to learn more about when we get into stats, especially if you're fortunate to take my stats 2 course. We'll spend more time on this kind of design. But generally here, I'd want to do a pre to post test design, right? Pre to post test. So I'd maybe have happiness before taking sunshine pills, happiness after, and maybe again um, 6 weeks later, right? You'd have the intervention, and then you'd have the result, right? Study end, and then you go after that, you do like a follow-up to see how well it lasts. So maybe I'll have 3 measures, and then I'll have between groups, or yeah, between groups, because we'll have several different groups, right? High, moderate, low, and placebo, and then the interaction between the two. That's really important because that's what we want to know. We want to know, is there a difference in the effect from pre to post, given whether you're in the low, placebo, high dose, etc. So we're looking for this interaction, a time by dosage interaction. So it's interesting, right? Designing a study, it puts together all the knowledge you have of everything. So I'm doing, even though I've gone over this with students before. Obviously, it's an assignment. Not an assignment, it's something that I do with you all. I don't do it every day, so I have to kind of remember things or build them from scratch. And I'm like building it from scratch now. But it's because I have all this knowledge about research that I can do this. So, given the research design, what statistical analysis do you propose using for your data? I would say a mixed ANOVA. I'd call this a mixed ANOVA. So we'll learn about those, especially when you're doing your grant writing course. This should be there's an assignment we do for that project for that, and you're going to propose it's a mixed ANOVA. Can you remember that for the summer? Sample size approximation. Well, we always have to pick a sample size. What in order to determine whether we have a significant effect, it depends a lot on your sample size. A sample size depends on your alpha, or your probability of a false positive result. If you don't remember what that is, you can look it up now, but we'll talk about it in stats. But alpha is your probability of a false positive result. That's kind of sets the base for what we consider statistical significance. What is your power? Well, see, in determining sample size, you're going to use some kind of a statistical package like G power, which I actually don't have downloaded on this computer. I have to call the help desk to get it to download because I'm not allowed to download things on my own, as none of us are at LaSalle. But G-Power is a program that will help you calculate sample size. Sample size approximation is probably the most important thing you have to do in research. In fact, I have to, somebody asked me to do it right now. Well, they have the sample, they need to know what the power is. The power is the probability of rejecting a false null hypothesis, and we set the standard at zero point 0.8. We don't want it to be zero point 0.7, we don't want it to be zero point 0.9 or even 1. This is a perfect number for us where it's not too high or not low. Right, so I can give you some criteria here. So sample size has an impact on power. Large sample sizes increase power significantly. So that's going to affect your alpha because alpha tells you how easy it is for you to reject the null hypothesis, right? Because alpha sets the like a barrier beyond which you have statistical significance, right? So if we have a really large sample size, we're kind of overpowered, and there's a reason for that. You'll see it next semester. maybe remembered from stats, I don't know. But you're going to have this effect, so you're going to change your alpha, right? So this is going to affect what your choice is. So there's a lot you need to think about here. Will it be a one or two tail test? Yeah, a lot to think about. One or two tail. We think of that in terms of a normal distribution that has tails. When we're doing it, we our determination of tailedness of our test is related to whether or not we're going to test if there's a significant difference in general, whatever. Like there's a sunshine pill that people take. Did the groups differ in happiness? That would make a we wouldn't be specifying in which direction. Like, are people happier or less happier with increased doses, or is there a specific direction in that relation? So that'll tell us whether we'd use a one or a two tail test. If there is a direction, we'll use a one tail test. One tail tests are more powerful than two tail tests. So I'd like to do that if possible. We also have something called an effect size. So these are these standardized measures of the effect of what of treatment. Like say if I am taking a drug to treat a headache, I mean, what would you consider a significant effect? To me, though, be a great effect would be if one dosage, I have no headache. I get sinus headaches and it takes several doses for it to go away, several hours, right? So that would be a one dose has a very small effect in my view. Two doses has more a better effect, and then three dose. So what's it three doses over several? I don't know whatever the hours are. It seems to work for me, right? So that's what we mean by an effect, but an effect size is a standardized measure, and we have ways of doing that. So here's an example of Cohen's d, which looks at the difference in means between, say, if we're doing two groups and we're comparing means, and it uses this pooled variance or standard deviation if you want, but it's basically a variance, pooled variance. The correlation coefficient is also a measure of effect, and this is one you have t values here. But anyway, you have these heuristics for what is considered a significant effect based on the or what the strength of the effects, right? Based on some heuristics, right? We have correlations. Point 0.1 is a small effect, so point 0.3, I'd say point greater than point 0.1, less than point 0.3 would be a medium effect. Point 0.3 to point 0.5, or point 1 to less than point 0.3 would be a small effect. Greater than point 0.3 to less than point 0.5 would be a medium effect, and point 0.5 and above would be a large effect. So, but we need to know that because those are all important in determining the sample size. We have to deal with recruitment. Who is the ideal participant? So this is tough. So we have to go through a lot to figure out who's the ideal participant, who we should rule out. I mean, in your text, the author talks about situations where you can make errors, where people can make errors in ruling people out. If you're going to rule people out for a study for because of some criteria, you got to rule it out for people in all groups. It can't be just people in the control group or the experimental group alone, because that's going to have a massive impact on your results. So you want to make sure you do it uniformly for everybody. Generally, we want to be careful with who, like if I'm doing a study on mindfulness and its effects on depression, I probably want to rule out people taking an antidepressant because that would could be a confounding variable. Again, what is your plan for recruiting participants? How are you going to recruit them? Usually people do things like advertisements, or sometimes they do, well, either in print or in or websites or just like pop-ups. Sometimes they'll do cold calls, sometimes there'll be ads in public transportation, and will participants be offered an incentive? Incentives are important to help you recruit participants. You just have to be careful in how you give them out. They can't be coercive anyway, because that's something the institutional review board is always looking at. The IRB wants to know the risks of the study. What are the risks of participation in the study on on potential participants. This could be physical, psychological, or loss of information. We're really concerned about that. What measures will be taken to minimize the risk? What measures? Oh, yeah. So you want to, what measures will we take in case a participant experiences an adverse event? You have to actually delineate all of this stuff, right? You can't just you can't not do that. Like when, for instance, I was thinking about this with writing a consent form for participants to a study. When we do a consent form, we want to make sure that all of this information is there, including who to call if you have a problem. Because when they sign a consent form, we'll give them a copy of the information. Uh, Also telling them that they're free to leave the study at any time without any consequence. There can be no consequences. Like, oh, you can't go to LaSalle after this. No, no, you can't have any consequence. And then data collection, what procedures will participants undergo? See, you just want to talk about everything that'll happen. Like a, like how will data be collected? Like often we went to schools to collect data, so we'd go to a classroom and it'll take this much time. And giving a timeline also would be helpful. Like just tell me a timeline from start to the end of the study, from soup to nuts. Yeah, so there's some good information discussed there. I think also there was in the go back here. I think this is where I go, right? Maybe. Why is it not working? Emma, they're not cooperating at the moment, but oh, seems like it's frozen. Yeah. Seems like it's frozen at the moment. Oh, here it is. Okay, good. Yeah, in chapter 15, there was a discussion about bias. And to be honest, there was a statement here that I really disagreed with. Where was it? Where is it? Let me look about this. Selection bias. So, as I did mention that it's really important to not have differential recruitment in your levels of your independent variable. So you can't have, well, there was an example given with a study um, with this I forget what the pill was for, and there was a possible link between taking this pill and breast cancer, but the researchers ruled out participants from the control group who had certain exposures, like they had other surgeries or they had heart disease, but they didn't rule those individuals out. Oh, they were taking that drug. Oh, here it is. It's a classic example of selection bias was demonstrated in 1974 with the publication of data appear to suggest a relation between use of reserpine and the risk of breast cancer, right? So they reviewed one of these studies from Helsinki. It was this one here. Women with breast cancer were compared to women without breast cancer. Women with newly diagnosed breast cancer were identified. Okay, da, da, da. They served as cases, and each was paired. So these are a match study, right? They were paired by age and year of their operation. So that's what we mean by matching and having like we talked about matching the other week, right? There was something interesting here. They had this odds ratio that was really, really big, right? So this is one of those case control studies where we had matching. So we look at the the discordant pairs, right? So 45. So these were the ones who were exposed, right, among the cases. Those are the more interested where there was an effect, and the controls where there wasn't an effect. So here the cases use RES or Pine and the controls did not. So it's 45. And then here's where the controls did use it and the cases didn't. So we're looking at 45 divided by 23. We get this really nice odds ratio. So here a problem was recognized. However, the method used for selection of controls and selecting the controls, the authors excluded women who had had the following surgeries: cholecystectomy, thyroidectomy, thyroid toxicosis, surgery for renal disease, and any cardiac operation, right? So, et cetera, right? They were excluded because at the time the study was conducted, reserpine was used was one of the agents used in the treatment of these conditions. They were concerned that if patients with these conditions were included in the case control study, the prevalence of reserpine used in the controls would be artificially high. Oh, that's great. So we'll just exclude them, right? So that what that'll do is reduce the exposure among the controls, right? It reduces the exposure among the controls, right? See how it was 23 here. It might have been higher. If it was higher, then the odds ratio wouldn't be 45 divided by 23 or 1.96. I'm laughing because that's that's a selection bias issue, right? That's an issue of bias, right? Because you're excluding participants who should have been included in the study, right? You're excluding participants who should have been included in the study, and that has a direct effect on this odds ratio. So now you have this inflated odds ratio, which looks like there's a real problem here, right? When there may not be. Because if we didn't exclude those participants, would our odds ratio still be 1.96? So the problem wasn't that they excluded them, but was that they excluded them only from the controls. They should have excluded them from the cases as well. You can't just exclude from one group. So that's what we mean by bias. Bias is when we treat individuals differently, right? We're treating them differently in this case in the controls versus the cases, and that has, as you see, that has a mathematical impact. It's crazy, huh? But there was something that I saw that really, well, then there were some other researchers who actually did a study where they found um, they kind of invalidated this study, right? There's something that I saw here that these guys try to blame everything on the researchers, and I think that is wrong. Yeah, I think that's a problem that they have. So the the authors tended to say that issues of bias are a research design issue. So basically, it's it's a problem that was caused by the. Oh, here it is. I completely disagree with this statement here. This is actually, I think it's wrong. A point to remember. Let's Yeah, a point to remember is that bias is a result of an error in the design and the conduct of the study. The example I gave you, yes, it was, but not in all cases, because if I'm doing a study where I'm doing a case control study and there's a tendency for cases to remember exposure more so than controls because they had, more traumatic experiences, is that really the fault of the researcher, or is that just the nature of a case control study? So what are you going to do? You're not going to do the study? I mean, you could do that. In that case, okay, yeah, you can say, well, I just can't do this kind of study because we have this like recall bias. So recall bias will be higher among cases than controls. So should we just not do the study at all? I'd say no. I think I would say here, instead of efforts should therefore be made to reduce or eliminate bias. But the second part, at the very least, to recognize it and take it into account in interpreting the finding. That is important. That part is important. But I disagree with the statement and say it's an error in the design or conduct of a study. It's sometimes it's just an inherent problem. I don't know, how is it an error if it's an inherent problem? Yeah, yeah, people can argue. I like to argue sometimes. So I mean that's an important issue here. So this is you want to take a look through this entire chapter. I mean, they talk about confounding. We've talked about confounding. They talk about mediated and moderated effects, which we've already discussed. They also talk, it's interesting, they talked about one way to control for confounding is to do a stratified type of analysis or stratified type of assignment. That's something that you can do, right? Like if you want to, so the goal here is not to necessarily just eliminate confounding variables, but you got to deal with them because they're going to be there. And one way to deal with them is to, I said, when you're assigning people, and I think we may have talked about this, if not, if you're assigning individuals to different groups, you're doing a study, right? You want to first stratify. Like here, in this example, you have cancer rates among non-smokers and smokers. and the results are stratified by level of urbanization. This reminds me of like when we did age adjustment, right? When we did age adjustment, we stratified by age, that therefore we controlled by age. So here, if we stratify by urbanization, we can look at odds ratios or relative risk, right, among those who are in a non-urbanized area, those who are in a city, and we can see if there's differences in those relative risks or odds ratios. So that's one way to deal with confounding variables. So the truth is, you should always anticipate confounding variables and have a plan for what to do with them. Either you can do nothing with them at all, but then you have to acknowledge it, or you can include them in the study. I tend to like to include them as either interactions or a mediator. So, this is basically the same kind of stuff that we were talking about. Interesting. This is an interesting chapter, and when we have your final, I'll expect that you be able to discuss these issues. Okay, I'm not going to have you memorize all the different types of bias because I mean one of the things I've learned from being a researcher is that you memorize less, you just have a good library, right? You always have a good library, so you can always look up the stuff you need when you need it. But you definitely want to understand and read about it to be exposed to it, right? So you want to be exposed to it. Yeah, so this is these two chapters are pretty good. So please read through them. And yeah, so next week we're doing a an final exam preview. Can you believe it? The semester's already almost over. Time flies, and these holidays that doesn't make it any easier. But thank you and have a great night.